Hello, quantitative literacy students. Let's take a look at the first lesson. So again, I recommend you access the course from the course homepage. This is week one. As you work through the course, it's not a bad idea to collapse everything and then you can just expand the week that you want. So the other stuff's not in the way. So expanding just week one here, I want my first lesson. And let's get started. So here we're going to look at some information that involves math, numbers, quantitative information. So quantitative information is just any information that has numbers in it, a quantity. And we're going to look at large numbers and rounding numbers. So the situation here, we're traveling down the highway and we see this billboard. And on the billboard, it says, ever since 1950, the number of American children gunned down has doubled. Okay. So you don't see a name of the organization that put up the billboard. Question here is, what groups might have wanted to publish this statement? What are some social issues or political ideas that this statement might support? Now, there's no right or wrong answer here, and we don't even have any numbers to work with. So again, what I just want you to do is take a moment and think about what groups might have published this statement and what issues are involved in the support of this statement. And so just write a couple of sentences down here in the box, and I will take a look at them later this week after the majority of students have submitted those. So feel free to pause this and write stuff down, and then we'll move on. I mentioned earlier, quantitative information is information involving numbers. Now, this one is a little bit vague. It kind of references the idea of number because it says the number and it says the number has doubled, but we're not actually given a number. So this technically isn't quite quantitative information. You might say, well, there's a year. Yeah, but the year isn't the most important thing here. It's the number of children who were gunned down, which we don't have. So this doesn't quite qualify as good quantitative information. It's vague. Now, some more information. In 1995, an article was published, the statement in the problem situation. Do you think this was a reasonable statement to make in 1995? Right, so that statement appeared in a published article in, 1995. The statement references 1950. All right, so we only have the information that was given there. How can we decide if the statement is reasonable? So this is pretty open-ended. There's really no right or wrong answers. Just think about that for a minute. Ever since 1950, the number of American children gunned down has doubled. We're reading this in 1995. 45 years later, might be a good time to get out a calculator. My favorite calculator is Desmos Scientific. There's also a Desmos graphing calculator. I recommend the Scientific. It's a nice one. So again, we take 1995, 1950, right? 45-year difference, just confirming what I did in my head. Since this is a math class, we should be writing stuff down. So I've got a notebook over here. Excuse me. So let's see some notes here. 1995. Oops, I should reverse that order. 1950 to 1995. Children gunned down. Doubled. Well, I really don't have enough information to say this is reasonable or not because I don't know how many were gunned down there and how many there are here to see if it's reasonable. So just on face value, maybe they say there were 10 there and 20 there, right? That's doubling times 2. So let's think about that. Oh, every year. So in 1951, it doubled. 1950 and 1952, it doubles again. Oh, that's a little more difficult than I thought. Doubled every year. All right, so at first glance, I'm not sure this is reasonable, because now I think I need to do something like write down 1950 and 1951 and 1952 and so on, all the way up to 1995. So if I started with 10 here, then it would be 20 there and 40 there, and then I got to figure out how many that is here. This is getting interesting. So again, here, we're not looking for a numerical answer. We just want to answer these questions. Oops, wrong one. I'm down on this one. Using only the information we have here and above, we want to state if this is reasonable or not. So at the moment, it doesn't seem that reasonable to me because there's really not any quantitative information given. That's what I would write. Okay, so here they're telling me to start with 1. Well, if it's doubling, then this would be 2. 1952 would be 4. 53 doubles again, 8. Isn't too bad. Doubles again, we get a 16. 55 double again, that's a 32. And I got to work my way up to 1960. So here's a place where I can do 2 things. I could whip out a calculator or a spreadsheet. So if I start here, starting with 1, check out this trick. Type 1 and then hit enter. And then do answer times 2. Enter, and then keep hitting enter. So that would be 52, 53, 54, 55, 56, 1957, 1958, 1959, 1960, if I counted right. 512 if I counted right. Okay, now I mentioned before, I should double check this before I hit submit, because if I don't get it right on the first try, now there's a hint here you could check out. How many years have gone by from 1950 to 1960? That would be 10 years, and the hint says I could use a power. So what is, let's see, 2 raised to the 10th power? Ooh, 1024. So this is saying I missed a year. All right. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. I miscounted. So it's 1024. Okay. For those of you who want an extra check on that, I would write out all of those years and the numbers, kind of like I started doing in my notes here. So fill in everyone up to 1960 to be extra certain. So I would have 1953 and 54 and 55 and 56, 57, 58, 59, and 1960. And I'm just doing 1. So it would be 8, 16, 32. You get the idea. Do something to double check. Put in your answer, check it. Now we've got 1960. And I think I have a trick to do 1970, right? So that was 2 to the 10th years later. So this should be times another 2 to the 10th because it's 10 more years of doubling. So I think 1970 would be whatever 2 to the 20th should be. Oh, that's a lot. Okay. Another way to check this would be to whip out a spreadsheet. So I like using Google Sheets, which I usually start from my Google Drive. And usually I'll have a folder for the class. So somewhere in my classes here, I have a Math 62 folder. And in my Math 62 folder, I would put a spreadsheet for this. Now I already have a lot of stuff in there. That's okay. So what would a spreadsheet look like for this? And this is pretty cool. So she give it a name. And I need to put the year in there and the kids gone down. I'm just going to call it kids for now. And I started in 1950 and then 1951. And spreadsheets have a pretty remarkable way of doing patterns. So if you highlight a pattern of 2 or more, then let go, then point to the bottom right corner and fill, it'll extend whatever pattern you set up. So here I jump by 1, so it's going to keep doing that. So I can make that go up to 1995 or 2013. All right, so the trick is start the pattern and then highlight to show. Now here's a little bit different. I want 1, and then I want to multiply by 2. So to do that, in the next cell I do equals, click on the cell above, and then do times 2. And in this case, since it's a formula like that, I just want to fill down that single formula. So if that didn't make sense, rewind the video a little bit and try it again. And what I should see is that in 1960, I get the 1,024 I found. In 1970, I should get the 1 million I found. And now I can see in 1995, I get this crazy number. I'm going to format these as numbers to get some commas in there, get rid of the decimal places, and make that a little bigger. That's a lot of people, holy crap. All right, so I think I've given you enough information to keep going on this assignment. So I'm going to stop here, keep answering questions on this assignment here. We have 1 page of stuff. Some assignments have more than 1 page. So once you're done answering all these questions, you're done with this and you're ready to move on to the next assignment. Keep up the good work, stay in touch, do good math. I will see you soon. Bye-bye.